Please start recording now.
Okay, done.
Tell me when you start.
Yeah, I already started.
Yeah, thank you. Okay, fine. We have already assigned all the addresses on R2. Let's jump into R3 and just simply do the verification if we have assigned the addresses. Brief. So you can see at 0/0/0, this is the left arm of the R2, which is 1.1.2. The right arm of the R2 is 2.1.1.1, and this is our loopback, and all the interfaces and up and up. Okay, fine. Let's jump into R3. So give it name as R3 and access the interface, the left one. So interface gig 0/0/0, sorry, 1. IP address is 2.1.1.1.2/8, and just go to the right arm of R3, which is 0/0/2. You can see in the diagram. The IP address we need to assign is 3.1.1.1/8. And also we need to configure the loopback 0. So the IP address of this device is 13.1.1.1/32. All right. So verification display IP interface brief. So you can see on the left arm we have assigned 2.1.1.2. On the right arm we have assigned 3.1.1.1, and on the loopback we have assigned 13.1.1.1. Okay, let's jump into the R4. Go to the system view and give the name as R4, and access the right arm, which is gig 0/0/2, and we need to assign this IP address, which is 3.1.1.2/8. We need to assign the loopback interface loopback 0, and the IP address is 14.1.1.1.1/32. All right. So what we have done till yet, we simply assigned the IP addresses of all the physical interfaces and on all the loopback interfaces. So we need to run OSPF. Again, we are going to start from R1. So simply, we will run the OSPF with process ID as 1, OSPF 1, and you can see the relevant areas where we need to assign which interface into which area. I have already labeled the diagram. So let's start from R1, OSPF 1, and don't forget to configure the router ID, which is 11.1.1.1.1. Just jump into the area 0 and advertise your network. First, you need to advertise your loopback 11.1.1.1 and the wildcard mask, because this is the single IP address, and then 1.1.1.1 and the wildcard mask all zeros. That's it. Now take the console of R2. The same process, OSPF1, and configure the router ID, which is 12.1.1.1, and just jump into area 0 first, and then advertise two networks. One is your loopback, and the other one is the left arm of R2, which is 1.1.1.2, and the wildcard mask all zeros. Okay, just jump into area 1, because we need to advertise the right arm of the R2, which is network 2.1.1.1, and the wildcard mask all zeros. Okay, that's what we have done at AR2 site. Okay, take the console of R3 and run the same process, OSPF1, and first configure the router ID, which is 13.1.1.1, and jump into the area, which is area 1, and advertise two network in area 1. The one is loopback, and the other one is the left arm of R3, which is 2.1.1.2. Put the wildcard mask. That's it. Okay. Sorry, we need to advertise this right arm into area 2 as well on R3. So we need to go back and we need to go into area 2 because the right arm of R3 is in area 2. And this network, definitely 3.1.1.1 with wildcard mask, all zeros. Okay, let's jump into AR4 and OSPF1 with router ID 14.1.1.1 and put the area, which is 2, and advertise two networks. One is your loopback 14.1.1.1 with all type mask zeros, and the network, the physical interface 3.1.1.2 and the wildcard mask, all zeros. And that's it. We have done all the configurations of multi-area OSPF. All right. Oh, sorry. People are not watching. I'm doing a mistake. No, perfect. Area 2. All right. So let's do the verification. I'm simply jump into R1 device. This is over R1. And I will check the routing table of R1. So display IP routing table. And if you can see, we have one network over here, second network over here, and the third network over here. And we have four loopbacks. This one, this one, this one, this one. So I have seven entries, I should see the 7 entries over here. All right. So let's do the verification. Display IP routing table. Okay, can you see that this is my directly connected? Okay, fine. It should be in the routing table. No problem. Loopback is my directly connected loopback. Okay, fine. No problem. I'm receiving this network, which is in area 0 through OSPF through ABR. Okay, fine. This is 2.0.0 through OSPF. Good. I'm receiving this loopback in my routing table, 12.1.1.1 through OSPF. Okay, fine. I'm receiving this loopback, 13.1.1.1 through OSPF. Okay, fine. But now you can see I don't have any entry of this network and of this loopback. I cannot see in my routing table. Why? Because you know the reason. Now you know the reason. What's the reason? Why I'm not receiving these routes into my routing table? That means if I try to communicate with this loopback 14.1.1, let's try to communicate. Example ping 14.1.1.1. So you guys can see I'm not getting any response. Why? Because I cannot see this route into my routing table. So my router is saying I have no entry against this network in my routing table, so I won't be able to communicate with him. So if I try to ping, for example, if I try to ping 12.1.1.1.1, the loopback of R2, you can see I'm getting the response. I'm able to communicate with him. If I try to ping 13.1.1.1.1, you can see also I can communicate with him. But the entry which is not in my routing table, I'm not able to communicate with them. Yes, this is clear to everyone.
Yes.
Is this clear?
Yes.
Yeah, it's clear.
Yes, clear.
Okay.
Can I just ask a question, please?
Go ahead.
When the routers, they share their routing tables. So AR3, it has 14.1.1 in its table, right?
AR3,
Yes.
this 14.1.1?
Yes, it has in its routing table how to send messages to 14.1.1, right?
No. Let me show you. Display IP routing table. Yeah, you are absolutely right. But the point is, can you see this? This belongs to area 2. This interface
Yes.
belongs to area 2, and because this belongs to area 2, they are exchanging the routes. They are exchanging the route with each other, but only the routes which are in area 2. All
And
right,
then
because 13.1.1 is the directly connected loopback of this device.
yes.
But if you remember, I told you if a router resides in between two areas, it will manage two separate databases. It will manage two separate databases. It will manage the database of area 1 separately and area 2 separately. So it
Okay.
won't exchange the routes between area 1 into area 2.
Okay.
Is that fine? You're
Yes,
absolutely
thank
right.
you.
In R3, we can see this loop back just because this router also belongs to area 2. So the routers, number of routers, there might be 10 routers, there might be 15 routers in a single area. They will exchange the route with each other. But at the same time, if you add another area and both areas are normal or regular areas, they won't be exchanging the routes with each other. So if you see the routing table of AR4, this will make clear. Display IP routing table. Can you see the 13.1.1.1 over here? Can you see? Can you see that this loopback? Is it sharing this loopback with AR4? No, because this loopback is resides in area 1. So area 1's routes are not being exchanged with area 2 routes. Is it clear? Why I can
Yes,
see this? Why can I see this loopback over here? Because this router also belongs to area 2, but this router only belongs to area 2. This router does not belongs to area 1. That's why they are not exchanging the routes from area 1 to area 2. I hope this is clear to everyone. That was a good question. That was a good question. So what's the solution? We need to find a solution. Okay, fine. We are violating the multi OSPF designing rules, but there should be a solution. This is not much recommended, but somehow we need to resolve it out. And how we can resolve this? We can resolve this by creating a virtual link. A virtual link. Now the question is, what is virtual link? And let me show you one more thing. At AR3, if I can show you, display OSPF brief. Yeah, this one. Can you see this router, this R3, which resides in area 1 and area 2? Simply, this is a border router. This is not an area border router. If I show you the same results in R2, display OSPF brief. So can you see the difference? This is your ABR, area border router, but this is your simply border router. This is not area border router. Why? Because there was a condition of ABR. There was a condition of ABR, and what was the condition? Condition was at least there should be one interface which is in the area 0, which is in the backbone, and all the rest areas can be in the regular area or normal area. This router is called ABR. But you can see this is area 2 and this is area 1. So it wouldn't be acting like ABR. It's simple. It is simple border router. You can see over here, simple border router. Okay. And I will show you the change after implementing the solution. I will show you the results. So we need to find what is the solution, and the solution is virtual link. So what we do when we create a virtual link, we simply expand our backbone area. We simply expand our backbone area. How we can expand our backbone area? There are two conditions. And the conditions are, for example, this is my device, which is R2. How many areas this device consists? In 2 areas. For example, area 0 and area 1. These are the common areas of R2. And what about R3? R3 has 2 areas, area 1 and area 2. I'm just creating the sets. I'm just creating the sets of R2 device and R3 device, how many areas they do have. So the first condition is where you want to create a virtual link, you need to figure out between 2 devices, and in between 2 devices, one device should have the backbone area. Obviously, I'm going to create a virtual link. I'm going to expand the backbone area. So for that purpose, we have some specific conditions. And the first condition is wherever you want to expand your backbone area, find out the device where you have at least backbone area. And the other condition is in between these 2 routers where you want to expand the backbone area, they should have a common area in between them. And you can see area 1 is common in between R2 and R3. So that means I will expand my backbone area till to area 1. What does that mean? That means I will start expanding area 0 from here, and from where I can expand, where there is an area 1, I will expand my backbone area. You got the point? I need to expand my backbone area, and from where to start? Obviously, I will start from R2, and where I need to end, where area 1 ends, I need to expand till that. So when I will expand this area 0 till R3, which resides in area 1 as well, you will see I will start getting the routes, this one and this one, into the routing table of R1. And yes, this is not the recommendation that you create so many virtual links. For example, again, there you have another branch, and here you can figure area 3, and now you start expanding backbone area from here to till there, and then again you have another branch, and you are continuously expanding your virtual link. This is not the recommendation. Yeah, if you face problem, you can create one virtual link. You can create more than one, but this is not the recommendation. That would be your bad design. You will face different challenges. So the recommendation is you can create one virtual link, but yes, you can create more than one virtual links, but these are the not recommendations. Anyone? Do you have any question? How we will expand this? Obviously, we are going to do the configurations, but I'm just delivering you the concept why we need to create a virtual link and what are the conditions. And the condition is, for example, I know I want to extend my virtual link till R3, and I need to create the sets of R2 and R3. And the condition is in between two devices, one device should have the backbone area. Obviously, you will start to expand the backbone area from here, from this device, and the both devices should have one area common, that is area 1. That means we need to build an overlay of backbone area over the area 1, and that's it.
Excuse me, sir. I have
Yes,
one question.
sure.
Yeah, like in this area 3, for example, if we expand and take one more router like in A3,
Yeah.
now if we make the sets of, for example, if we consider as it R3, then if, sorry, R3 and R4, there won't be any backbone, right? A0 won't be here.
Yes.
So how can we configure that one? How can we virtually link that one? Where there will be,
Obviously, first you need to expand the backbone area till that device, till a R3. Then you will start further. So definitely, it's impossible if you talk about R3 and R4 and R4 to R5. So I won't be having the backbone area at R3. So we need to expand the backbone area first till R3. Then we will talk about the further branches. All right.
okay, thank you, sir.
It seems impossible. No?
Yes.
Yeah. Yes. Anyone else? Okay. So how we do configure? This is only a single command. There is only a single command for this configurations. So I need to expand the backbone area, and I need to start from R2, and I will end at R3. So I need to do the configurations at R2 and R3. And the configurations are very simple. The configurations are very simple. What we need to do at R2 side, I will simply say OSPF1, OSPF1, and already we have configured router ID, and I will jump into area 1, and then I will simply say uh, virtual peer link, virtual peer, virtual peer mean neighbor, and obviously I need to assign the neighbor router ID over here, neighbor router ID. That's why I was configuring the router ID as a loopback interfaces. It is not necessary that loopback should be the router ID. You can configure that interface as well as a router ID, but you need to provide the neighbor identification. By sitting at R2, you need to provide the router ID of your neighbor to whom you want to create, you want to expand the virtual link. And by sitting over here at R3, you need to do the same configurations. You will go to OSPF1 and you will go into the specific area. And then you will simply say V peer link, virtual peer link, or peer router ID. By sitting over here, you will provide the router ID of your neighbor. And while sitting over here, you will provide the router ID of this neighbor. And this is a single line command configuration, single line command configuration, and that's it. Okay, let's do that, and let's see the results. So first you need to verify, for example, display OSPF peer brief. I want to check the brief of my interfaces, and you can see by sitting at R2, I have two neighbors, R1 and R2. Right now, my concern with my right neighbor and this neighbor, which is connected with this interface, what's the ID? 13.1.1. If you don't know what's the neighbor router ID, what's the neighbor router ID, you can see by this command, by this verification. Why should we need expand the area? That's what we were discussing, and that's what we have discussed. I'm not able to see the routes. I'm not able to see the routes of. Did you join the class right now? iPad, please mention your real name. Nawaf. Okay. Nawaf, when you joined the class? Because it's been in half an hour we are discussing about these topics. So why we are expanding the backbone? Because we have backbone over here. I have backbone over here. I have another regular normal area over here, and the other regular and normal area over here. So this is against the violation of the OSPF designing. So I'm not getting the routes of this area into my backbone. So I need to access these routes, because if I'm not accessing these routes, I won't be able to communicate with them. So that's why I'm expanding my backbone area, so that I would be able to receive the routes of this area. That's why I'm expanding my backbone area. Thank you. So I was saying, if you don't have any idea what is the neighbor ID, what is the neighbor router ID, you can check by this command, display OSPF peer brief, and you can see the right arm by sitting at R2. This is my right arm, and this is the neighbor where I want to expand my virtual link. So you can check what is ID, what's my neighbor ID. So it's 13.1.1.1. And you can also verify by sitting at R3 with the same command, display OSPF peer brief. Show me the peer brief. So over here you can see, by sitting at R3, I want to check the router ID of my neighbor, of this neighbor, which I'm connecting with 0/0/1. And you can see the loopback interfaces we have configured as a router ID. So the router ID of this is 13.1.1.1, and the router ID of this is 12.1.1.1. So you need to verify, you need to check the router IDs. Otherwise, you won't be able to configure virtual link. All right. So you need to provide the router ID of your neighbor while you will be creating the virtual link. So by taking the console of R2, let's jump into OSPF1 and area 1. And here you need to put the question mark, and there are so many commands over here, but we need to take this last one, vlink pair, virtual link pair. So vlink pair, and then put the question mark, and you can see what he is expecting from you, the neighbor router ID, the neighbor router ID. So you need to provide the ID of your neighbor, and which is 13.1.1.1. And this is the command to create the virtual link, and that's it. But you need to do the same configurations from R3 side. So I will jump into R3 and the same commands, OSPF1, area 1, and then vlink pair, and put the question mark. Again, he's asking for the neighbor router ID. So you need to provide the neighbor router ID. And right now we are sitting at R3, and we need to provide our neighbor ID, which is 12.1.1.1. So you need to provide 12.1.1.1 over here. And that's it. That's how we create virtual link. That's how we expand our backbone area. So you can see there are some remarks. That means something is going on. So I need to verify this on R1. And let me show you the previous table. That was our previous table. where we don't have any entry, of 3.0 network. We have 1.0.0, we have 2.0.0.0, but we don't have 3.0.0, and we don't have 14.1.1.1 over here. All right. So let's do the verification. Either we are receiving display IP routing table, and now you can see this 3.0.0.0 I'm receiving now, and 14.1.1.1 through OSPF. They have been advertised into my routing table. Now, if I want to access the loopback of R4, which is 14.1.1.1, you can see the reply is coming. But before creating the virtual link, I wasn't able to get any response from 14.1.1.1. And if you want to see the routing table of R4, this is the previous routing table before configuring the virtual link. I cannot find any entry. These are the directly connected interfaces. So now if you run this command, display IP routing table again, you can see all the entries. 1.0.0, which is running over here. I'm accessing this through OSPF. The 2.0.0, I'm accessing this through OSPF. And 3.0.0.0 is my own network. And then all the loopbacks, 11, 12, 13, 14, all the loopbacks. 14 is my directly connected, but I'm getting 11, 12, and 13. And if you want to check the connectivity, if you want to ping the loopback of R1, you can see the replies coming. So we have performed conversions, but at this time, we have created a virtual link. Virtual link means we have expanded our backbone so that we can perform conversions, so we can get the routes. Okay, guys, is there any question related to this virtual link lab configurations?
Yes. What will be the difference if we expand? I mean, we include router 3 inside backbone area and expand. Why we didn't expand? I mean, we include router 3 inside area 0, backbone area, instead of expand area. What's the advantage? I mean,
in multi-area OSPF lab, keep one thing, remember, there can be only one backbone. You cannot create multiple backbones. First thing, when you design multi-area OSPF, there should be only one backbone area. You cannot configure more than one backbone. And from your question, I have expanded backbone area till R3. Now this is your backbone. This is your backbone. This is your backbone. And this is your backbone, and the rest R3 is connected with, for example, R2, A2. So now you can see we are fulfilling the conditions of multi-area OSPF. We have backbone, and backbone is directly connected with the normal or regular area. And obviously, inside this backbone, we have another area, which is area 1. It doesn't matter, but we have expanded our backbone till R3. You got my point?
yes. Thank you.
Okay, so I guess now see that before creating the virtual link, I have shown you that that was not mentioned over here. That was not mentioned over here. About the R3, he was simply calling it as border router. And now after creating a virtual link, can you see that? Now the status has been changed. It's saying this router, this R3 is area border router, area border router. And now if you know the definition of ABR, you can imagine what are the condition of ABR. At least one interface should be towards the backbone, and the rest interfaces could be into any area. That's why he's calling it as area border router. And if you have forgotten, let me show you the previous output.
It has
if I can show
expanded
you.
and became in the area itself, the backbone area.
Yes, this is the previous output. Simply what is written over here, the border router. But after configuring the virtual link, now you can see the difference. Now he's calling it as area border router. So there are so many ways to verify what we have done. The simple verification we have checked by checking the routing table. That's what we need. But other than that, you can verify by so many ways. So guys, any question? We have done with this topic, the virtual link, and we have also performed the lab, how to expand over backbone area. So far so good. Fine. Okay, we have to discuss some types. We are talking about two areas. One is your backbone area, and you can say the other one as non-backbone areas. The regular and normal areas are also called non-backbone areas. So from the non-backbone areas, we have multiple types. Multiple types of areas. We have stub area. We have totally stub area. We have not so stubby area, and we have totally not so stubby area. We have multiple types of non-backbone areas, and these multiple areas are not be configurable on the backbone. So we are not talking about the backbone. We are only talking about the non-backbone. Non-backbone means your regular areas and normal areas. So we have further types of areas, but under the umbrella of regular or normal areas. So what are these areas? We need to figure it out. But first of all, we need to discuss about the LSA types. Because without understanding the LSA types, you won't be able to understand these multiple areas. So in OSPF, we have LSA, link state advertisement. In OSPF, because we have multiple types of routers, so we have multiple types of LSA. What I'm saying? I'm saying in OSPF, like we have different routers types like ABR and ASPRs and backbone routers. So that's why we have multiple LSA types. So we have a number of LSA types till 11 and 12, but we won't be discussing LSA 6 and the rest of the LSAs. So we only be discussing LSA 1, 2, 3, 4, 5, and 7. So what is LSA 1? What is LSA 1? Let me draw a topology over here. And this is really very important concept. Before we start LSA types, let me deliver you a concept about the DR and BDR and DRO. DR means designated router. DR means designated router. BDR means backup designated router. And other than that, all the routers are called DRO, DR others. DR others. So I guess in previous slides, I have added this topic. Let me check if I have the slides. This one. Yeah. Yes. Yeah. DR and BDR. So what are DR and BDR? He says within the local network means we are talking about multicast network, multicast network. We are not talking about point to point, P2P. And local network means multicast network, multi-access network. Local network means your LAN. So within the local network, the router with the highest router ID is elected as DR. He's telling about the election that there are so many routers and who is going to be elected as DR, there would be an election, and who will win the election which has the highest router ID, The highest router ID will be elected as DR, and the second highest elected router ID would be selected as BDR. But what are the roles of DR and BDR? For example, I have configured the router ID as 1.1.1.7 and 1.1.1.6. Over here, I have 1.1.1.1 and 1.1.1.2. Okay, fine. If a new router added and it comes with the new interfaces, obviously you people know if this router has 4 entries, for example, 1, 2, 3, 4 into the routing table. Okay, fine. This router also have the 4 entries, 1, 2, 3, 4 in the routing table. All right. And this router also has the 4 entries in the routing table. And this router also has 4 entries in the routing table. They have performed convergence. But suddenly a new router came and it takes number of networks along with this device. So we can suppose this is your 5th entry in your network. So in order to perform convergence, what you can expect? What should be happen? Okay, guys, from you. If there is another entry, the 5th entry, anyone please can elaborate? They have shared all the 4 routes and they have performed convergence, but now there is new entry.
It will change the database for all of other routers, of all routers.
Perfect. Anyone else, please?
Yes,
Yeah,
the fifth router should be added.
Okay. This route should be added. This route should be added into the routing table of each router, on each router. And all the rest entries, which was already in the routing table, they should be advertised with this new person so that he can also complete its routing table 1, 2, 3, 4. That's what you were expecting. But how this happens? The question is how this happens. If this new entry exchange it new route with all of them, and then whenever it will add the new entry into the routing table, it will also share its routing table with all its neighbor. That I have a new entry, I'm sharing my LSA with you, and make sure you add this entry as well. It will exchange this entry with him, and when it will add this route into the routing table, he will be sharing that entry with everyone else, and resultantly there would be the broadcast flood. Everyone will be sharing with everyone in this domain. It's just like there is a class and there are 50 students. And over here, this is your professor, which is standing over here. And suddenly a new student came into the room. And instead of introducing himself to the teacher, he start introducing himself with all the students by going one by one, And then all the students will introduce this new students with each other, And what will happen? There will be a great noise in your class. So what should be the solution? Solution should be this new student will introduce himself to the teacher that I am a new student, my name is this, my father name is this, and this is my ID, this is my roll number. And then this teacher will announce this student with everyone. They all will listen and will remember his name and his roll number, and that's it. So what should be the better and appropriate solution? Solution 1 or solution 2? What should be the better approach?
Solution 2.
Obviously solution 2.
Solution 2, yeah.
So that's why to reduce the broadcast, to minimize the broadcast, we elect a DR. We elect a DR in OSPF. We elect a DR, the designated router. And what's the job of designated router? The job of designated router is whenever a new entry join your network, it will only inform all his related information to DR only. And on which address? On 224.0.0.6. And this is the multicast address of DR, reserved for DR. And for example, this is the highest router ID and this is selected as DR. So OSPF will assign this multicast address to DR. And the second highest would be elected as BDR. BDR, it is a backup of designated router. In any case, if designated router goes down, it will take place of DR. It will be elected as a DR because this is the second best highest router ID in this scenario. So it would be elected as BDR. And all the rest devices are called DRO, DR others. And they only listen the multicast on 224.0.0.5. So remember, when we were discussing OSPF yesterday, I told you there are 2 multicast addresses in OSPF that has been reserved. So one for DROs, which is 224.0.0.5, and DR listens on both addresses, 224.0.0.0.5. It listens on both devices. But whenever a new entry came into the network, it only advertised its LSA to DR only. Then DR will update its routing table and will send this routing updates. It will multicast this routing updates on which address? On 224.0.0.5. Then what will happen? All the DROs will receive that updates, and that's it. DRO itself won't be sharing any routing updates with any DRO. Only the DR, the designated router, will exchange the routes, will exchange the updates on this specific multicast address, and we know DR others only listen on this multicast address. So whatever the exchange and routing exchange will be shared by DR, all the DROs will receive that updates and will update their routing table, and that's it. So the actual reason to elect a DR is to minimize your multicast or broadcast traffic. And that's it. You got my point?
Yes, but I do have a question.
Sure.
Okay, regarding the IP address of the DR, it should be always 24, or it is reserved for the DR, or it could be from this class.
No. It has been reserved for DR.
Okay,
Yes.
great. Thank you.
Okay. For example, DR is selected on the highest router ID. But if we don't want to play with the router IDs, we can change the priority. We can play with the priorities. For example, all the routers, all the 5 routers has priority of 1 by default. But if I set the priority as 10, and for this I set 5, this would be elected as 10, and this would be elected at 5, and all the rest would be elected as DRO, because by default they have priority 1. And if you want some router do not participate in the DR, BDR, DRO elections, you can set the priority 0. You can set the priority as 0. When you put the priority set as 0, this router won't be participating in the DR and BDR elections. Is there any question?
Sir, I have one question.
Sure.
Yeah, like regarding that router ID for the DR, if we
Yeah.
introduce a new router, if that is having the highest router ID, so the
Yes.
DR will be changed or not?
No, unless you restart the OSPF process. Your question is very good. If and the question is, let me share with other people. If there is another router, the newly router which joined over network, and it has the highest IP 1.1.1.10, should it would be selected as new DR? No, not at all. Unless you restart the OSPF process, and restart the OSPF process means you want to perform an election again. If you perform an election again, then it will be selected as PR. All right. I hope this is the answer of your question.
How can we restart OSPF?
So DR and BDR, within a local network, the router with the highest router ID is elected as DR. The second highest is elected as BDR. In some cases, an administrator may want specific routers to be DR and BDR. You can select at your own choice. These might be routers with the more processing power or the lighter traffic load. Hopefully, if you have this router, which is your new router, and it has the great resources, it has great processor, it has a great memory. So you want this router to be selected as DR. So then you will play with the priority. You will set the highest priority of this router, and this will be elected as new DR. All right. The highest priority setting will win the election for the DR, regardless of the highest router ID. If you set the priority, it will check the priority. A value of 0 signifies that the router is ineligible to be DR or BDR. If you want this router won't be able to participate in the DR BDR election, you can set the priority 0. All right. So this is an example of DR and BDR. So we have 4 routers: router 1, router 2, router 3, and router 4. And this is our multi-access network, multi-access local network. All right. So R1 is saying my priority is 0. I will not participate in the election of DR. So I am DR other. I want to be DR other. Okay. R2 says my priority is the default value of 1. So obviously I am DR other. Fine. R4 says, or R3 says my priority is 10. So I'm going to be the DR. And R4 says my priority is set by the administrator, which is 5. So I have compared my priority with you. So your priority is higher. Obviously, if you are the DR, so I'm the BDR, backup designated router. So that's how we play with the priorities. That's how we play with the priorities. So in this network, what we have decided that because of the highest router ID, for example, this is our DR and this has been elected as BDR, and these rest are DROs, DR others. 1.1.1.1 and 1.1.1.2, and for example this is 1.1.6, and this is our new router 1.1.1.3. So now you know, whenever this entry join our network, it share LSA with only DR, and this LSA is called LSA1, and we call it as router LSA. Router LSA. That means everything originated by this new router, Everything originated by a new router is called router LSA or LSA1. And what is LSA2, which we call as network LSA? The network LSA. Obviously, when this LSA about the new router is advertised to only DR, it will update its own routing table 1, 2, 3, 4, 5, for example. Then it will put this multicast address on this advertisement and will exchange these routing updates with all DROs, and this is your called LSA2, which is called network LSA. That means everything originated by the DR, everything originated by the DR is called LSA2, network LSA. I hope class is with me at this two LSAs.
Yes, sir.
What about the BDR?
BDR is the mirror of DR. Is a mirror of BDR. It's a backup of DR. Obviously, all the updates will be synchronized with BDR. All the DR updates will be synchronized with BDR immediately. Because if this DR goes down, obviously this BDR would be elected as new DR. So it should have all the updates. It should have all the mirror updates in this routing table or in its database. So this is a mirror of DR. Mirror means all the synchronization of databases and routing table will be updated with time to time without any delay. So these are two LSAs. So everything which is originated by the new router is called LSA7, router LSA, and everything which is originated by the DR is called LSA2 or network LSA. Okay, then we have further LSAs, which are LSA 3 and 4, the summary LSA, Both are the summary LSAs. But over here, he has written ASPR. So what are the summary LSAs? For example, if we have this topology, and for example, over here, we have backbone area, which is area 0. And over here, we have area 1. And we know this is our ABR, area border router. So can we say LSA1 is received by DR, LSA2 is sent by LSA2, sent by DR? Yes, absolutely, perfect. So this is our backbone area, and this is our normal area or regular area, or you can say non-backbone area. So all these routes, for example, 2.0.0 network and the loopback of R2, for example, 13.1.1.1, all the routes which backbone received from the other area, from the inter area, sorry, we call this inter area. Inter area means from different area. So all the routes which a router receives from another area is called LSA, LSA 3 and 4. Obviously, at your home, you have brother, you have sister, you have father and mother. So you call them as we are family member. We are family members. Family members. But whenever your cousins came to your home, you don't call them we are family members. You call them they are my cousins. They are my cousins. You distinguish. So OSPF make the distinguish between its own area routes and the routes which he is receiving from other area. And this ABR create the summary and send it to another area. That's why we called LSA 3 and 4 the summary LSA. And who performed this summary? Your ABR, area border router. Is that clear?
Yes, it's clear.
Perfect. So these are your LSA 3 and I'm adding LSA 4 with it because whenever it forwards the summary to another area, it also sends the gateway. It also sends the gateway if you want to exit from the OSPF to another AS. It also sends the gateway IP address, which you cannot see in your routing table. It can be shown in the database table. So it also sends the gateway of ASPR. That's why we call it as LSA4. You can say over here is written summary ASPR LSA. That means also ABR sends the summary of ASBR as well. ASBR means the gateway of the ASPR. So I'm receiving the gateway as well. So that's why I'm calling it as LSA type 4, the summary ASPR LSA. And the second, fifth LSA is very important. And the fifth LSA is, for example, if you have this kind of design and we are going to perform on this scenario, we are going to perform the lab on this scenario. So what we have, for example, let me shorten it. We are going to connect 3 routers only, 3 routers. So this would be R1, this is over R2, and this is over R3. Over here, we are running this network, and over here, we are running this network. And over here, we have the loopback 11.1.1.1 and 12.1.1.1. And over here, we have 13.1.1.1. So over here, we have configured area 1, for example, and over here we are configuring area 0, the backbone area 1 over here, and backbone area over here. And suppose that we are receiving some routes from another autonomous system, from another autonomous system. And I'm going to translate them, I'm going to redistribute them, I'm going to import them into my autonomous system, Because normally what happens, if you are running OSPF over here, here we are running OSPF, and for example, here we are running some other IGB protocol, for example, IS, or might be we are running RIP over here. So normally the OSPF routes will not be advertised to RIP, and the routes of RIP will not be advertised to OSPF, because both protocols have different routing policies. Both protocols have different cost parameters, and everything is different. You can simply say, for example, these are the Chinese, and uh, these are some, for example, look, Pakistani. So normally Pakistani speak Punjabi and Urdu. There are some languages, and obviously Chinese speak their own language. Say normally, if they don't understand Punjabi or Urdu, or Pakistani don't understand the Chinese, say they won't be able to communicate with each other. So they should understand the language of each other. So we need a translator over here. We need a translator over here as a third party. We need to translate the Chinese into Urdu and Urdu into Chinese. So same happens over here. What I'm saying, suppose that these routes are coming into my autonomous system from another autonomous system. So what we need to do, we need to translate them. We need to translate them. And when I will translate them, they will appear on my routing table on R1 and R2 as well. And these routes are called LSA5, which we called as external LSA. External means clear. That means they are external persons. They are not even my family members, and they not also belongs to my family, but they are external people. They are external people. They are unknown people. I don't know them, but I want them to be there at my home. All right. So these LSAs, which we receive from another autonomous system and translate them and redistribute them and import them, these LSAs are called LSA5, the external LSA. Is it clear to everyone?
Yeah, it's clear.
Yes.
Okay, fine. So I guess officially this is our break time, but what should we do? You want to break, or we can take the break at 11, and what we can tell me what you people want, when we should take the break.
I agree with the break on 11.
On 11. Okay, we will take the break at 11.
Yeah, it's
Then we'll be having a long break, including our tea break. So the lunch break and the tea break, we will add them up. All right. So let's do the lab. And after
The
this lab,
problem is because of the time difference,
yes.
our lunch break will not be included with the tea break because it will be 11.
Okay, fine.
For you, yes, because of the 2 hour difference. For you, it is
Yes.
lunch break. Yeah.
Okay, fine. We will do that with the mutual cooperation. No problem.
Yeah,
No problem.
okay.
Okay, we are going to perform this lab, and I want to show you how this LSA5 appears in the routing table. This is very interesting. This is very interesting because to meet with external people is always interesting. Okay, so
Yes.
already we have a lab, but we need to remove one router. We can remove that. Okay, we have removed that, and the rest of the configurations related to OSPF, I guess these are fine. We need to remove only the virtual link commands, and already we are running, but we need to change. So let me remove the configurations of OSPF only. So our design is different. So into OSPF1, yes, and here we need to remove the OSPF process and to OSPF1, yes. Yes. So what is our design? Our design is we are configuring area 1 over here, including the loopbacks of both devices and including the loopback and the physical interface. This would be over area 0. And I will define some static routes over here, and we will suppose that these routes are coming from an external AS. So how we will do that? Just let me quickly run the OSPF according to the label diagram. And now people know how to run OSPF. So 1.1.1.1 over here, 1.1.1.2 over here, 11.1.1.11, and 12.1.1.1, and 2.1.1.1 and .2 over here. And this loop back 13.1.1.1. Fine. So let's start the configurations. OSPF 1 and router ID has been removed. So 11.1.1.1 into area 1. Work 1.1.1.1 with alpha mask all zeros. Okay, 11.1.1.1 and the wildcard mask all zeros. Fine. And then on R2, if one with router ID 1.1.1 and put them into area network 12.1.1 and go to area 0. Is the right time 2.1.1.1. AR3 if 1 with router ID 30 area 0. Okay, that's all. So let's do the verification if we are getting the routes at R1. So you can see 1.0.0, 2.0.0, and all the 3 loopbacks. So this is perfect. Okay, fine. So we need to add some static routes at over R3. For example, if we take any kind of static routes, for example, 192 1.17.0, 192 1.18.0, and 192.1.19.0, and 192 1.20.0. I'm going to define 4 static routes at R3. And how we can define, we have already defined the static routes. You know how we define the static routes, but at this time, there's a little bit change. IP route static 192.1.17.0, 17.0, and destination mask, but as a next hop, I'm setting null 0. What does that mean? Why I'm setting null 0? 18.0, 19.0, and 20.0. So why I'm setting next hop as a null 0? Why? This is the same syntax. We are adding the destination. Obviously, the routes which are coming towards me, obviously they exist somewhere. So if I want to go on this network, that's why I'm over here. I'm saying that the destination this and the subnet mask this, but null 0. Why I'm not setting next hop or my outbound interface? Why I'm setting null 0? Anyone?
It's
I'm not
mean
sure, but
always up. I mean, it always will be up and up state, right?
No, these are not the interfaces. I'm simply defining static routes. I'm not defining them on a specific interface. So these are the not loopbacks. These are not specified on a physical interface. They don't ever exist anywhere. We are defining them just for the testing purpose, just for the testing purpose. Obviously, we don't have another autonomous system over here and we don't have any routes. Obviously, why I'm setting null 0? When I will be receiving that routes over here, so I will ping them. Whenever I try to ping them, if this if this router receives the traffic for the specific destination, it will put them into the basket. Why it will put into the basket? Because the destination, all the destination does not exist anywhere. They do not exist anywhere. So that's why I'm setting null 0 because I'm simply want to test them. Yes.
So it will prevent loopback, right?
It will.
Prevent loopback. I think this one task
No,
we
they are not even pingable. They are not even pingable. They are not even pingable. Why they are not pingable? Because I'm not defining these addresses on any particular loopback or any physical interfaces. No, we are just defining them for our lab purposes. So we cannot ping them. And why I'm setting next hop null 0? Because there is no next hop, there is no other router, there is no other autonomous system. So what I'm saying, if anyone wants to reach to this network, put them into the basket, null it, 0 it. Okay, they won't be getting any response whenever they try to ping these addresses.
Oh, I got it. Clear.
This is for the testing purpose. This is for the testing purpose. Okay, so we have defined these static routes. Let me show you the routing table of R3 first. So display IP routing table. So you can see these static routes which we have defined over here, 17, 18, 19, 20 by static means. And can you see that the next hop is 0? That means there is no next hop. They don't exist anywhere. So whenever you will try to reach them, you will not be getting any response. All right. But right now you cannot see these routes in the other routers routing table. For example, display IP routing table. You won't be able to see these routes coming here. There is no route. If you want to see the routing table of R2, let me show you this one as well, display IP routing table. You cannot see any routes. You cannot see any routes. Why I'm not receiving these routes? Can you please tell me? Anyone, please?
because they're not there already.
Because
they are not listed
They
in
are not there.
the database itself of the routers, the other routers.
yes, because we are expecting that we are receiving these routes from another autonomous system. So we haven't yet translated them. So there is a term in Huawei. Cisco use the term redistribution, and Huawei is called it as import route, import route. Import the route. Redistribution means translate the routes because they belongs to some other autonomous system. So this autonomous system might be running RIP and ISIS, any protocol, and over here what we are running OSPF. So we need to redistribute them. We need to translate them, we need to import them into the OSPF policies. So how we do that? How do we do that? By going onto the R3 and just simply go to your OSPF process and simply say import route. Whatever the routes you are receiving from another autonomous system, from another routing policies, from another IGPs, just import them into the OSPF. And what kind of routes are there? They are, you can see how many protocols you have and how many routes you have to import into the OSPF. You can import the routes of BGP, you can import the direct routes, you can import the routes of ISIS, then you can import the routes of OSPF from another autonomous system, the RIB and the static. So right now, what is overcase? Overcase is static because we have defined the routes statically. So I will import the route static and that's it. This is a single command to import the route, to redistribute the route, to translate the routes into your routing policies. Because right now we don't know what the routing policies are over there inside the another autonomous system. So we need to translate them. We need to translate them into our autonomous system. So that's how we do that. That's how we do that. We simply write import route, and we need to define what kind of routes they are. So right now we have defined them statically. So that's why I'm setting import the static routes into the OSPF, so that my other routers can receive that routes. So let me show you. Yes, I'm taking the console of R1 and display our IP routing table, and you can see and now I'm receiving these routes 17, 18, 19, 20, and now you can see the difference, how they are prompting into the routing table. That O means OSPF. That O means OSPF. Now they have been redistributed into OSPF, but I'm just mentioning the mark ACE. ACE means these are your external routes. They don't belong to the same OSPF process. Yes, I have imported them from another autonomous system. That's why you are accessing them. You are receiving them through OSPF. But keep remember one thing: these are the external routes. These are the ACE routes, and you can see the preference. The preference value is very high. Higher the preference, lower the priority. And the normal OSPF preference is 10. But the preference for external routes, for the external people, to our external people, these are 50. Higher the preference, lower the priority. So these routes are LSA 5, LSA 5, external LSA, external LSA. I hope this is clear to everyone.
Yes.
Okay,
Yeah,
fine.
it's clear.
Okay.
So I have a question. Can we modify the preferences?
Yes, we
What's
can.
the command for that?
Okay. If you want to change the preference, for that we need to create the prefixes, and there are some other stuff you need. You create the route policies. There are so many things, but if we check over here, import a route static, and you can set the type, and the type you can set type value. If I set the type value as 1, it will change the cost but not the preference. But if you want to change the preference of the AD value, we can change that. But over here, the cost and cost, I can define, I guess, 20. Let me define 20 over here. Let me see if it has been changed or not. No, it has been changed. The cost has been changed, but the preference is not. All the time we do Cisco versus Huawei, Cisco, Huawei. All the time we are having the training of Cisco and Huawei. So there's a mix and match.
Yeah, it will be confused.
Yes, Huawei says display, Cisco says show. Huawei
Yeah.
says redistribute, Cisco says redistribute, Huawei says import route. So there are a lot of things. So how we do change the preference? I can create the prefix list by just creating the route policy. I can change the preference. So let me do that for you if you want me to do that. For example, I'm creating the IP prefix with any name and the permit. So permit. For example, 192.1.17.0 is must match. Route policy with permit not match. Okay, fine. Okay, let's try. I have created a policy. So let me verify is it working over here or not. I'm just changing the preference of this network. Okay. So they have gone. I guess I have created a very dangerous policy.
It's damaged everything.
AR3. Okay. AR3. Okay, import static route policy loop, and inside that, what I've done, route policy loop permit not 10 if match if prefix loose, apply preference 25. So I guess these are the static with null zero. That's why policy is not implementing on them, because
Yeah.
I'm simply I was trying to. You can see. Okay, what you need to do if you want to change the preference. Obviously, you will filter that route to
Yeah.
whom you want to change the preference, and then you will create the route policy. And you see if the match with IP prefix, which I have created with this loopback, simply apply the preference. Apply the preference means change the preference 25.
Yeah.
So, and when you will import the route, import route static, you will call your simple route policy with a loop.
Yeah.
So if any loopback or if any prefix, which we have defined over here, match while importing the routes, it will call your route policy. So when it will call your route policy, in route policy, what you are doing, you are simply changing the preference. So that's how we do. So I do this every time, but this is, I guess, the static null routes. So that's why policy is not been implementing on
Yeah,
them.
maybe it's because it's not regular condition. This static do it and anonymous. Sorry.
Yeah.
No.
Yeah.
But it's clear. I thought.
Okay, fine. But you have seen, let me remove this policy, or one. So you can see these are our, we were trying something different. Nothing is related to our topic, so don't you worry at all what we were doing. So uh, that is what I wanted to show you people, that we have number of LSAs 5 types over here in our routing table. Okay, so I will let you know. I will do the lab for you. Tell me the name of that guy who was questioning, please.
Me?
How we can change the preference of this static routes?
Yeah,
Yeah,
me.
this is
Yusuf.
right now. Use.
Yusuf,
Okay,
Yusuf.
fine. This is later. Okay, well, sorry. Only fine, fine.
Yeah.
Fine. Is there any question related to your LSA 5, the external LSA? Okay, then if you don't have any question, let's have a break. And by the way, we will take the break of 30 minutes right now. Then after 1.5 hours, we will be taking the break again, because then I will be offering the prayer and I will be having the lunch as well. So I will allow you people to as well. So tell me if you want to have the break of 30 minutes, or you want 1 hour break or 1 hour 30 minutes break. Tell me, how do you want?
Half an hour, sir.
My all entire OSPF, and I can see these routes in the routing table of R1 as an external routes with preference 150. So all of them I can see. But just imagine these are the only four prefixes, 4 networks. If I'm receiving that route from ISP, then they might be millions of routes. And obviously, I want that million routes to populate in my routing table and increase the size of my routing table, because this device, this R1 or this R2, they won't accommodate the millions of routes because their resources are not much capable to maintain these or million of routes or thousands of routes. So, and you have to redistribute them into your autonomous system. But the normal areas and the regular areas, they don't need these routes. So I want to minimize the size of my routing table. So how can I do that? So to minimize the size of the routing table, and to just get rid of these all static routes and all routes which are coming from another autonomous system, and they could be thousands, hundreds, thousands, million, billion routes. So I want to stop them. I don't want them into my routing table. So what will I do? I will make this area as a stub area. And what will happen? All the LSAs 5, the external LSA, I won't see them into my routing table when I will configure this area 1 as a stub. It will stop all the LSAs 5 routes, the external routes. And obviously, you need to configure the area 1 as a stub, but you have to make it stub on R1 as well as on R2, because area 1 is the common area between R1 and R2. If area 1 has 5 routers, 10 routers, 15 routers, you need to do this on all the routers. You need to make this area as a stub area. And when you figure this area as a stub area, all the external LSAs will not be populated into your routing table. HBR will stop them. ABR, area border router, will stop them. And how we can do that? This is very simple. This is very simple. Now you can see still at R1, I can see these external routes, but I don't want them. I don't want them into my routing table. So how can I stop them? The same method is very simple. We'll go to OSPF process 1 and into your area 1, and you will make it stop. And that's it. You will make it stop. And just hit the enter button. And you need to give the same command on R2. The configurations are required on both sides because right now we have 2 routers in area 1. So go to a system view, jump into the OSPF process, hit the area 1 and make it stop. And that's it. And that's it. So if you want the verification, how we can verify? Just go to your R1 and display IP routing table. And you can see I'm not accessing the external routes, but right now I'm not accessing these routes as well, but it will take some time. It will take some time. After the time, you will see I won't be having that external routes. So wait for a few minutes. Now you can see the remarks are coming. And now you can see I'm still having all the networks which belongs to my own autonomous system number, but I don't have any ACE route, any external routes in my routing table in AR1. And the same you can see on the other route. If you run this command, this is, I guess, AR3. So I need to access AR2, R2. So in R2, run the same command, display IP routing table. You can see still here I'm still accessing the external routes. Would you please elaborate me why? Why I'm still having these external routes in R2? Why? While I'm not having the external route in R1. Yes.
Because R2 has 2 areas. It is a gate router and it has 2 different databases.
Yes, exactly. Because R2 also belongs to area 0. That's why this router is still having these external routes. But only this R1, which totally inside the area 1, it's not accessing that external routes. So what if that was a stub area? That was a stub area. That was a stub area. And what if I make it total stub? Totally stub area. And what is meant by total stub area? You can see right now still I'm having the routes which are coming from my intra area. These are the routes which belong to the same AS, but what if I don't want them? I also don't want them into the routing table. And how can I stop them? How can I stop them? For that, you need to configure area 1 as a total stub area, totally stub area. If you make area 1 as a totally stub area, although you have already stopped the external routes, you have stopped LSA 5, but what if you make it totally stub? Definitely you are refusing to access the LSA 3 and 4, which is, summary LSA. By making an area as a totally stub, you won't be able to receive LSA 5 as well as LSA 3 and 4. And there's a condition. If you want to make it totally stub first you need to configure it as stub. Then you can configure totally stub. This is a prerequisite. This is a prerequisite. You cannot configure directly totally stub area. First, you need to make it stub. Obviously, does it it does make sense. First, you need to stop your external LSAs. Then you will stop your own ACE routes from other area into your area. So how we can do that? Still, you can see we have these 2.0.0.0, which belongs to another area, and 13.1.1. Also, this is the loopback of area 0. So I don't want them into my routing table. Still, there are two, but this is back on. This might have thousands of routes. And I don't want to accommodate them into my routing table because backbone is very strong. It has number of routes. It could have 1,000, it could have million of routes. So I want to stop them because they are increasing the size of my routing table. I need to shrink the size of my routing table. So how can I do that? The configurations again are very simple. In R1, you will again access the process of OSPF1. You will jump into area 1 and you will say stub, and then you will add no summary. Obviously, there is no command. You might be thinking there should be a command which we can write like totally stub. No, there is no command like totally stub. First, you are making it stub, and no summary means no LSA 3 and 4. No summary means no LSA 3 and 4 because we called LSA 3 and 4 as a summary LSA. So if I'm writing no summary, that means I don't want LSA 3 and 4. And that means I'm making this area as a totally stub area, And again, this is a single command configuration, single line command configurations. So stub and then no summary. And you need to run the same command in this area on R2, OSPF1 and area 1. And you will say, first make it stub. And then I don't want no LSA 3 and 4. So I will write no summary. And that's it. Now, if you want to verify on R1, you will run the same command, display IP routing table. Now you can see I don't have any routes of area 0. Neither this loopback, which was 14.1.1.1, and nor this network 2.0.0.0. I cannot see over here. But against this, when I'm configuring stub and totally stub, the OSPF had created the default route. Because, for example, if I'm not getting these routes in my routing table, that means I won't be able to communicate with these routes? No. You should be able to communicate with them, but by using the default route. And we didn't configure that. We didn't configure the static default route. The OSPF configured that. So whenever you configure the stub and totally stub area, OSPF automatically generates the default route. And if you remember, when we was having a discussion about static routes, he has mentioned 2 or 3 things over here, I guess. Yes, over here. Yes, can you read this line? The default static route, it can be automatically generated using a routing protocol or manually can be configured. So last time we have configured the static default route manually, but this time this static default route is automatically generated by a routing protocol, which is OSPF. I hope this is clear to everyone. And this is interesting. Yes, are you with me, guys?
Yes, yes, it's clear.
Yes.
So that's how we make an area as a stub and totally stub. And what are the purposes behind to make an area stub and totally stub? I hope this is clear to everyone. What we are getting by making them stub and totally stub. Okay, fine. Then we have a last type, which is NSSA, the third type of special area, which is NSSA, not so stubby area, not so stubby area. If you break them into two portions, still it is a stubby area, still it is a stubby area, but not so, not so. It is, but not so. It will show you some flexibility. And what is that flexibility? Let me show you, but first we need to remove the initial configurations, which we have done right now, OSPF, and then I will go to area 1 and I will say undo stub. All right. So I will be getting all the routes again. OSPF 1, area 1, and we will say undo stop. So display IP routing table just after waiting a few seconds. Just wait for a few seconds. Let them advertise the routes. Now you can see. No, not yet. Now you can see. After a few seconds, you can see all the routes I have in my routing table. 2.0, 1.0, and all the loopbacks and all the external routes. Again, I am receiving all the routes. Okay, fine. So to understand the NSSA, not so stubby area, I'm going to configure some static routes on R1. Although we have configured some static routes on R3, which we can see in the routing table of AR1 and AR2. But let me configure some static routes over here. And what kind of static routes I'm going to configure over here? You can take any 200.100.50.0. For example, 200.100.100.0, this network, this /24, and 200.100.150.0 with /24, and 200.100.200.0 with /24. So let me configure these static routes over here on R1. So IP route static 200.100.50.0 with /24, and again I'm setting the next hop as null 0. And then again you can change the network by putting over here 100 and then 150 and 200. Okay, fine. So also I have to redistribute them into the OSPF. So how we do redistribution? So simply you will say OSPF1, import the route which I have defined statically. Okay, fine. So now you can see display IP routing table. On R2, you can see all the external routes, all the LSS files. These one, which we have defined over here, and these 4 static routes, which I have defined over here, and I have redistributed them into the OSPF. And also these static routes, we have advertised, we have redistributed them into the OSPF. So what I want now, what is my expectations and what are my requirements? The requirement is I don't want these routes into my routing table. I don't want these external LSAs into my routing table, but the routes which I'm importing at my side, I want to exchange them with every other routers which belongs to area 1 and which belongs to area 0 as well. So how we can do that? We simply go to R1. I will say OSPF1 and then area 1, and I will simply say NSSA. I'm saying this to area 1. Please be an NSSA, not so stubby area. And that's it. And you need to run this command on R2 as well. So you will go to OSPF1 and area 1, and you will say NSSA. And that's it. Not so stubby area. And this is your LSA 7. Especially this one, NSSA, is called LSA 7. LSA 7. We stop all the external LSAs, from another area, but it will exchange its all external routes to another area, into another area. If you want to verify, how we can verify? Let me do the verification. So display IP routing table. You can see I'm not receiving the static routes which I have imported from over here. All the static routes which I have defined over here, I'm not getting these routes on AR1. But what about these routes? What about these routes? I should be able to see them over here and over here. So let me show you. On R2, if you want to see display IP routing table, you can see I'm getting all the routes, that one and that one also. But you can see the difference. Now, these are not written as ACE routes. These are written as the routes which I have advertised. I have redistributed them over here. They are prompting in the routing table as ONSSA. But suddenly, if I look at the routing table of R3, you will see the difference. Display IP routing table. You can see over here, they are again appearing in the R3 routing table as an external LSAs. And why this is so? Why this is so? The static routes, which are defined over here, and I have redistributed them, I have imported them into the OSPF. Over here, I can see they are appearing just like this, just like ONSSA. And the same routes, which I can see on R3's routing table, I can see them as external routes. Why is it? Please, anyone can tell me? Anyone, please?
Regarding why it's ASE.
Why the same routes? Why the same routes which I have imported them into my area 1?
Uh-huh.
I can see the same routes in R2 as ONSSA, and the same routes at R3. I can see them as OACE routes. In fact, they are the same routes, but why they are presenting them in the different way, in two different ways.
Oh, okay. I think because R1 it has a common area with R2. Okay, but in R3 they are in different area completely. It's not common with R1.
All right. Perfect. Anyone else, please?
Yes, I guess you defined it once in R2 and an NSSA and an R1 and SSA, but you haven't
Yes.
defined it in R3.
Okay, fine. Anyone else, please?
NSSA carries the same information, but within the first network.
All right. Okay, fine. You are receiving OSPF. You are playing a trick with OSPF. Why are you playing the tricks with OSPF? Because this area 1, we have made this as NSSA, not so stubby area. So this has some restrictions as a stubby area. It's still a stubby area, but not so. That means whenever you configure any area as a stub area, it has the allergy of ACE routes. Whenever it sees the ACE routes, it stops them. So in fact, these routes are the ACE routes because we are getting them from another autonomous system. But whenever we configure NSSA, it has some stubbiness. It has the allergy from ACE routes. So if these routes again appear as ACE routes in area 1, it will stop them. But what we want to exchange these routes with another area. So how do we flirt with the OSPF? We change its appearance. So till that area, which is configured as NSSA, it has some stubbiness. Into that area, we change its appearance just to receive the OSPF algorithm. And once they leave that specific area, area 1, and jump into the another area, again, they adopt the same ACE routes appearance. That's the basic reason. That's the basic reason. You guys are also perfect. You guys are also perfect, but this is the actual reason. We are deceiving, we are playing a trick with OSPF algorithm. Because whenever you make us area as stubby area, it has some allergy with ACE routes. But in area 1, we change its appearance, pass them through area 1, and whenever they jumps into another area, they again adopt the same formation, the same symbols, the same appearance. You got my point? So there is a trick. There is a trick on OSPF that I don't want to receive the external routes, but I will generate my own external routes and I will redistribute them. I will exchange them with all of them. So that's the trick which played by an SSA, not so stubby area. And this is your LSA7. I hope class is with me at this point. This is very interesting.
Yes, following.
Yes.
Perfect. So that's all about OSPF. That's all about OSPF. We have done with the OSPF. We have a lot of things, but we have a lot of topics as well. So we need to discuss the other topics. So any question regarding OSPF, because we are going to start another topic. So if you guys have any question regarding OSPF, you can ask me. Otherwise, we are going to start our next topic. Just put yes or no in the chat box so that I can get the reply from you people.
For me, I don't have any other question.
All right.
Just I have an request. Can I change because I need to change my device, my laptop. So can I change to pass the record to my friend Nasser Al-Sagroubi to continue the recording?
All right.
If you
Just
can.
ask him. Just ask him. Just
Okay,
ask
yeah,
him.
I can start record.
Okay, let me give you the
allow me now.
permission. Yeah,
Yeah,
I'm going to allow you the permission.
I will
So
stop
allow to
recording
record.
now.